Hello and welcome everyone. My name is Piyush and I am a solutions architect based out of US West. This is a series of lightning talk on ECS and Fargate with the objective of making you all familiar with Amazon ECS, which is a fully managed container orchestration service. Today we'll talk about a way of interconnecting services using ECS Service Connect. Connecting services reliably is not trivial. With containers, we typically use a lot of microservices. As the number of microservices we create keeps on growing, so does the complexity of communication between your microservices, considering we may have multiple versions of these microservices coexisting. In addition, the dynamic nature of underlying infrastructure, as well as the health check, which would remove unhealthy endpoints that your application has to reason about, also adds to this challenge of reliable service communication. In the world of Amazon ECS ecosystem, there are a variety of ways to interconnect services. Some of these options, like ECS Service Discovery, are easy to get started with. You create your ECS service, give it a friendly DNS name, and your application can use the DNS name to talk to your tasks directly. ECS Service Discovery uses Amazon Cloud Map in the background, which is an interface to add DNS records to an Amazon Route 53 private hosted zone. There are shortcomings with Amazon ECS Service Discovery option as they lack features like traffic telemetry and provide fairly basic discovery capability owing to the DNS limitations in terms of smart discovery capabilities. Moving on, there are options like elastic load balancers for interconnecting services, wherein you get rich traffic metrics, features like DDoS protection. The downside is that for communication inside the VPC, all these features prove to be an overkill in a lot of cases. But now you have to be responsible for provisioning, managing this additional infrastructure, and it's in the path of your request flow, which would be something you may look to avoid, especially for latency sensitive workloads. Then there is this feature rich managed service mesh solution, which we have made available for our customers, known as AWS App Mesh, which relies on an open source Envoy proxy sitting next to your Amazon ECS tasks. They collect metrics on your behalf. You have fine grained traffic controls. You can enable authentication and encryption. However, now you have this added complexity wherein you are responsible for the proxy management as well as you now need to reason about Envoy proxy configuration. Working backwards from our customer feedback, we launched Amazon ECS Service Connect, which checks all the boxes. It's simple as it offers simple naming scheme and simple discovery mechanism. It offers reliable connectivity with automatic retries for failure and network level health checks. And it offers rich metrics both in your Amazon ECS console as well as on the Amazon CloudWatch dashboards. Next, let us zoom into these Amazon ECS Service Connect features, starting with simplicity in terms of naming scheme and discovery mechanism. You can assign a friendly name to your services, and services are organized in namespaces. The clients can use a combination of service name and namespaces to connect to ECS services, as shown here. These Amazon ECS services can span across multiple Amazon ECS clusters. As long as they belong to the same namespace, they can talk to each other. Let us see this in action. I have the ECS cluster set up with a Yelp-like voting architecture, letting you vote on your favorite restaurant deployed on the ECS cluster. With front-end UI service, the UI service talks to the back-end app server. The app server in turn stores the data in PostgreSQL and Redis cache, and I've also have a Cloud Map namespace set up as well. Here is the application portal wherein you can vote on your favorite restaurant and the pie chart would get refreshed with your voting preference. Let's navigate to the AWS console, and in order to enable Amazon ECS Service Connect at the time of creating ECS service within the service configuration YAML file, you will need this block of Service Connect configuration wherein you turn on Service Connect and you specify the Cloud Map namespace that you want this service to get registered to. The outcome is that all the services in this Yelp Service Connect 1 internal namespace will be able to talk to this newly created service, and so would this service be able to talk to every other service in the configured namespace. The discovery name gets registered in the cloud map and is used by clients to call the service. Alternatively, you can see the client aliases configured here, an optional setting which could be useful for existing clients from migration standpoint, and client alias defines a friendlier DNS name which can be used to call out the service. Next is the reliable service to service connectivity. We perform an outlier detection, detecting problems within individual container and task, for instance, when they return 5xx error. Next, we take those erroneous tasks out of traffic routing, and all this happens at the network level. Additionally, Amazon ECS Service Connect automatically retries failed calls, so the calling application never gets to experience the task level issues for TCP, HTTP1, HTTP2, and gRPC connections. Going back to our three-tier microservices architecture, let us take a look when one of the app server tasks become unhealthy and hence unreachable all of a sudden. The app server has an API endpoint that can be used to dynamically inject fault so that the subsequent API call would return with 503 response code. Let's validate that two of the three app server instances are configured for fault. If you can see, the only instance that's returning HTTP response code 200 is the one ending in 98186. Now, the front-end calling service would never see the failed requests, and if we access the application, we see no errors, even though two of the three tasks are returning 503 response code. If you inspect the network traffic while using the application, you'll see that all the API calls are returning HTTP 200 status code. Behind the scenes, Amazon ECS Service Connect is able to reroute the app server API request to a different endpoint, which is healthy, and therefore the calling UI service does not see the failing error on an ongoing basis. Next, from an observability standpoint, you get rich telemetry for TCP, HTTP, and gRPC metrics either on ECS console, Amazon CloudWatch, or any other third-party solution based on your preference. In addition to metrics, you can send logs to your preferred Amazon ECS log provider using Amazon ECS Service Connect. Let us navigate to CloudWatch console, and under metrics, click on all metrics and choose ECS. Amazon ECS Service Connect brings more application visibility, and you can now see new dimensions grouped by cluster name, discovery name, service name, and target discovery name. Next, let us see one of the ECS service named UI service. And you can now see health and metrics once you enable Amazon Service Connect. Inside health and metrics, you can see the CPU and memory utilization at the service level. On the outgoing traffic health, you'll see different response codes returned by your dependent services, how many requests you have sent to your dependent services. You'll also see the response time to receive a response back from your dependencies and the associated processed bytes. With all this information, if anything goes bad with a specific dependent service call, you'll be able to easily find that out. That concludes today's talk about a way of interconnecting services using Amazon Service Connect. We'll see you next time.